Have you ever wished for a single package that you could easily install that has everything you need for local AI? Well, I have good news for you today because I have exactly what you are looking for. I have actually never been so excited to make a video on something before. Today, I'm going to show you an incredible package for local AI developed by the N8N team, and this thing has it all. It's got Ollama for the LLMs, Qdrant for the vector database, Postgres for the SQL database, and then N8N to tie it all together with workflow automations. This thing is absolutely incredible, and I'm going to show you how to set it up in just minutes. And then I'll even show you how to extend it to make it better and use it to create a full RAG AI agent in N8N. So stick around because I have a lot of value for you today. Running your own AI infrastructure is the way of the future, especially because of how accessible it's becoming and because open source models like Llama are getting to the point where they're so powerful that they're actually able to compete with closed source models like GPT and Claude. So now is the time to jump on this, and what I'm about to show you is an excellent start to doing so. And at the end of this video, I'll even talk about how I'm going to extend this package in the near future just for you to make it even better. All right, so here we are in the GitHub repository for the self-hosted AI starter kit by N8N. Now, this repo is really basic and I love it. There are basically just two files that we have to care about here. We have our environment variable file where we'll set credentials for things like Postgres, and then we have Docker Compose, this YAML file here, where we'll basically be bringing in everything together like Postgres, Qdrant, and Ollama to have a single package for our local AI. Now, the first thing that I want to mention here is that this README has instructions for how to install everything yourself, but honestly, it's quite lacking. And there's a couple of holes that I want to fill in here with ways to extend it to really make it what I think that you need. And so I'll go through that in a little bit and we'll actually get this installed on our computer. Now, there are a couple of dependencies before you start. Basically, you just need Git and Docker. So I'd recommend installing GitHub Desktop and then Docker Desktop as well, because this also has Docker Compose with it, which is what we need to bring everything together for one package. So with that, we can go ahead and get started downloading this on our computer. So the first thing you want to do to download this code is copy the git clone command here with the URL of the repository. You'll go into a terminal then, and then paste in this command. For me, I've already cloned this, that's why I get this error message, but you're going to get this code downloaded on your computer, and then you can change your directory into this new repository that you've pulled. And so with this, we can now go and edit the files in any editor of our choice. I like using VS Code, and so if you have VS Code as well, you can just type in code dot, and this is going to pull up everything in Visual Studio Code. Now, the official instructions in the README that we just saw would tell you at this point to run everything with the Docker Compose command. Now, that is not actually the right next step. I'm not really sure why they say that, because we have to actually go and edit a couple of things in the code to make it customized for us. And that starts with the .env file. So you're going to want to go into your .env file. I've just made a .env.example file in this case because I already have my credentials set up. So you'll go into your .env and then set up your Postgres username and password, the database name, and then also a couple of N8N secrets. These can be whatever you want. Just make sure that they are very secure and basically just a long alphanumeric string. And then with that, we can go into our Docker Compose file. And here's where I want to make a couple of extensions to really fill in the gaps. So the couple of things that were missing in the original Docker Compose file. First of all, for some reason, the Postgres container doesn't have the port exposed by default. So you can't actually go and use Postgres as your database in an N8N workflow. I think N8N uses Postgres internally, which is why it's set up like that initially, but we want to actually be able to use Postgres for our chat memory for our agents, and so I'm going to show you how to do that. Basically, all you have to do is go down to the Postgres service here, and then just add these two lines of code right here. Ports, and then just a single item where we have 5432 mapped to the port 5432 inside the container. And that way we can go localhost 5432 and access Postgres. So that is super important. Otherwise, we won't actually be able to access it within an N8N workflow. And we're going to be doing that later when we build the RAG AI agent. Now, the other thing that we want to do is we want to use Ollama for our embeddings for our vector database as well. Now, the base command when we initialize Ollama is just this part right here. So we sleep for 3 seconds, and then we pull Llama 3.1 with Ollama. And so that's why we have Llama 3.1 available to us by default. But what I've added here is another line to pull one of the Ollama embedding models. And we need this if we want to be able to use Ollama for our RAG. And so I've added this line as well. That is very, very key. So that is literally everything that you have to change in the code to get this to work. And I'll even have a link in the description of this video to my version of this. You can pull that directly if you want to have all of the customizations that we just went over here. And with that, we can go ahead and actually start it with Docker Compose. And so the installation instructions in the README are actually kind of useful here because there's a slightly different Docker Compose command that you want to run based on your architecture. So if you have a NVIDIA GPU, you can follow these instructions, which are a bit more complicated, but if you want to, you can. And then you can run with a GPU NVIDIA profile. And then if you are a Mac user, you follow this command right here. And then for everyone else, like what I'm going to use in this case, even though I have a NVIDIA GPU, I'll just keep it simple with Docker Compose dash dash profile CPU up. And so we'll copy this command, go into our terminal here, and paste it in. And in my case, I have already created all these containers, and so it's going to run really, really fast for me. But in your case, it's going to have to pull each of the images for Ollama, Postgres, N8N, and Qdrant, and then start them all up, and it'll take a little bit because I'll also have to do things like pulling Llama 3.1 for the Ollama container. And so in my case, it's going to blast through this pretty quick because it's already done a lot of this. I did that on purpose so it can be a quicker walkthrough for you here. But you can see all the different containers, the different colors here that are running everything to set me up for each of the different services. And so like right here, for example, it pulled Llama 3.1, and then right here, it pulled the embedding model that I chose from Ollama as well. And so at this point, it's basically done. So I'm going to pause here and come back when everything is ready. All right, so everything is good to go. And now I'm going to actually take you into Docker so we can see all of this running live. So you're going to want to open up your Docker desktop, and then you'll see one record here for the self-hosted AI starter kit. You can click on this button on the left-hand side to expand it, and then we can see every container that is currently running or ran for the setup. So there are going to be 4 containers, each running for one of our different local AI services. And we can actually click into each one of them, which is super cool because we can see the output of each container and even go to the exec tab to run Linux commands within each of these containers. And so you can actually do things in real time as well without having to restart the containers. You can go into the Postgres container and run commands to query your tables and stuff. You can go into, actually, I'll show you this really quick. You can go into the Ollama container and you can pull in real time. Like if I want to go to exec here, I can do Ollama pull llama 3.1, if I can spell it right, 70B. So I can pull models in real time and have those updated and available to me in N8N without having to actually restart anything, which is super, super cool. All right, so now is the really, really fun part because we get to use all the local infrastructure that we spun up just now to create a fully local RAG AI agent within N8N. And so to access your new self-hosted N8N, you can just go to localhost port 5678. And the way that you know that this is the URL is either through the Docker logs for your N8N container or in the README that we went over that was in the GitHub repository we cloned. And with that, we can dive into this workflow that I created to use Postgres for the chat memory, Qdrant for RAG, and Ollama for the LLM and the embedding model. And so this is a full RAG AI agent that I've already built out. I don't want to build it from scratch just because I want this to be a quicker, smooth walkthrough for you. But I'll still go step by step through everything that I set up here, and so that you can understand it for yourself and also just steal this from me because I'm going to have this in the description link as well. So you can pull this workflow and bring it into your own N8N instance. And so with that, we can go ahead and get started. So there are 2 parts to this workflow. First of all, we have the agent itself with the chat interaction here. So this chat widget is how we can interact with our agent. And then we also have the workflow that is going to bring files from Google Drive into our knowledge base with Qdrant. And so I'll show the agent first, and then I'll dive very quickly into how I have this pipeline set up to pull files in from a Google Drive folder into my knowledge base. So we have the trigger that I just mentioned there, where we have our chat input, and that is fed directly into this AI agent where we hook up all the different local stuff. And so first of all, we have our Ollama chat model. And so I'm referencing Llama 3.1 colon latest, which is the 8 billion parameter model. But if you want to do an Ollama pull within the container, like I showed you how to do, you can use literally any Ollama LLM right here. It is just so, so simple to set up. And then for the credentials here, it is very easy. You just have to put in this base URL right here. It is so important that for the URL, you use HTTP, and instead of localhost, you reference host.docker.internal. Otherwise, it will not work. And then the port for Ollama is, if you don't change it, 1143.4. And you can get this port either in the Docker Compose file or in the logs for the Ollama container. You'll see this in a lot of places. And so with that, we've got our LLM set up for this agent. And then for the memory, of course, we're going to use Postgres. And so I'll click into this, and we're just going to have any kind of table name you have here, and will create this automatically in your Postgres database. And it'll get the session ID from the previous node. And then for the credentials here, this is going to be based on what you set in your .env file. So we have our host, which is host.docker.internal again, just like with Ollama. And then the database name, user, and password, all three of those you defined in your .env file that we went over earlier. And then the port for Postgres is 5432. And so with that, we've got our local chat memory set up. It is that simple. And so we can move on to the last part of this agent, which is the tool for RAG. So we have the vector store tool that we attach to our agent, and then we hook in our Qdrant vector store for this. And so we're just going to retrieve any documents based on the query that comes into our agent. And then for the credentials for Qdrant, we just have an API key, which this was filled in for me by default, so I hope it is for you as well. I think it's just the password for the N8N instance. And then for the Qdrant URL, this should look very, very familiar. HTTP host.docker.internal. And then the port for Qdrant is 6333. Again, you can get this from the Docker Compose file because we have to expose that port, make it available, or you can get it from the Qdrant logs as well. And so one other thing that I want to show that is so cool with hosting Qdrant locally is if you go to localhost port 6333, like I have right here, you can see in the top left, /dashboard, it's going to take you to your very own self-hosted Qdrant dashboard where you can see all your collections, your knowledge base basically, and you can see all the different vectors that you have in there. You can click into visualize, and I can actually go and see all my different vectors, which this is a document that I already have inserted as I was testing things. So you can see all the metadata, the contents of each chunk. It is so cool. So we'll go back to this in a little bit here, but just know that like you have so much visibility into your own Qdrant instance, and you can even go and like run your own queries to get collections or delete vectors or do a search. It's just really awesome. So yeah, hosting Qdrant is a beautiful thing. And so with that, we have our Qdrant vector store, and then we're using Ollama for embeddings, using that embedding model that I pulled, that I added to the Docker Compose file. And then we're just going to use Llama 3.1 again to parse the responses that we get from RAG when we do our lookups. So that is everything for our agent. And so we'll test this in a little bit, but first I want to actually show you the workflow for ingesting files into our knowledge base. And so the way that works is we have two triggers here. Basically, whenever a file is created in a specific folder in Google Drive, or if a file is updated in that same folder, we want to run this pipeline to download the file and put it into our Qdrant vector database running locally. And so that folder that I have right here is this meeting notes folder in my Google Drive. And specifically the document that I'm going to use for testing purposes here is these fake meeting notes that I made. I just generated something really silly here about a company that is selling robotic pets, an AI startup. And so we're going to use this document for our RAG. I'm not going to do a bunch of different documents because I want to keep this really simple right now, but you can definitely do that. And the Qdrant vector database can handle that. But for now, I'm just using this single document. And so I'll walk through step by step what this flow actually looks like to ingest this into the vector database. And so first of all, I'm going to fetch a test event, which is going to be the creation of this meeting note file that I just showed you. And then we're going to feed that into this node here, which is going to extrapolate a couple of key pieces of information, including the file ID and the folder ID. And so once we have that, I'm going to go on to this next step right here. And this is a very important step. Okay, let me just stop here for a second. There are a lot of RAG tutorials with N8N on YouTube that miss this. When you have this step at the end here, I'm just going to skip to the end really quick. Whether this is Supabase, Qdrant, Pinecone, it doesn't matter. When you have this inserter, it is not an upsert. It is just an insert. And so what that means is if you reinsert a document, you're actually going to have duplicate vectors for that document. So if I update a document in Google Drive and it reinserts the vectors into my Qdrant vector database, I'm going to have the old vectors for the first time I ingested my document and then new vectors for when I updated the file. It does not get rid of the old files or update the vectors in place. That is so important to keep in mind. And so I'm giving a lot of value to you right here by including this node. And it's actually custom code because there's not a way to do it without code in N8N. But it is all good because you can just copy this from me. I'm going to have a link to this workflow in the description, like I said, so you can just download this and bring it into your own N8N. Take my code here, which basically just uses LangChain to connect to my Qdrant vector store, get all of the vector IDs where the metadata file ID is equal to the ID of the file I'm currently ingesting, and then it just deletes those vectors. So basically, we clear everything that's currently in the vector database for this file so that we can reinsert it and make sure that we have zero duplicates. That is so, so important because you don't want different versions of your file existing at the same time in your knowledge base. That will confuse the heck out of your LLM. And so this is a very, very important step. And so I'll run this as well. And that's going to delete everything. So I can even go back to Qdrant here, go to my collections, and you can see now that this number was 9 when I first showed this Qdrant dashboard, and now it is 0. But it's going to go back up to 9 when I finish this workflow. So next up, we're going to download this Google Drive file. Nice and simple. Then we're going to extract the text from it. And so this, it doesn't matter if it's a PDF, a CSV, a Google Doc, it'll take the file and get the raw text from it. And then we're going to insert it into our Qdrant vector store. And so now I'm going to run test step here, and we're going to go back to the UI after it's done doing these insertions. You can see here 9 items because it chunked up my document. So we'll go back here and I'll refresh it. Right now it's 0. I'll refresh. And there we go. Boom. We're back up to 9 chunks. And the reason that there's so many chunks for such a small document is because if we go to my chunk size here in my recursive character text splitter, I have a chunk size of 100. So every single time I put in a document, it's going to get split up into 100 character chunks. So I want to keep it small just because I'm running Llama 3.1 locally. I don't have the most powerful computer, and so I want my prompts to be small. So I'm keeping my context lower by having smaller chunk sizes and not returning a lot of documents when I perform RAG. And so the other thing that I wanted to show really quickly here is my document data loader. And so, or my default data loader. I'm adding 2 pieces of metadata here, the file ID and the folder ID. The more important one right here is the file ID because that is how I know that a vector is tied to a specific document. So I can use that in that other step right here to delete the old document vectors before I insert the new ones. So that's how I make that connection there. So that's kind of the most in-depth part of this walkthrough is how that all works and having this custom code here. But just know that this is so, so important. So just take this from me. I hope that it makes sense to an extent. I spent a lot of time making this work for you. So yeah, with that, that is everything. We've got our agent fully set up, everything ingested in. We have the document currently in the knowledge base because I ran through that step by step. And so now we can go ahead and test this thing. So I'm going to go to the chat widget here. Actually, I'm going to save it first and then go to the chat widget. And then I'll ask it a question that it can only answer if it actually has the document in the knowledge base and can retrieve it. So I'll say, what is the ad campaign focusing on? And because this is Llama 3.1 running locally, it's going to actually take a little bit to get a response because I don't have the beefiest computer. So I'm going to pause and come back when it has an answer for me. All right, so we got an answer from Llama 3.1, and this is looking pretty good. It's a little bit awkward at the start of the response here, but this is just the raw output without any instructions from me to the model on how to format a response. And so you can very, very easily fix this by just adding to the system prompt for the LLM and telling it how to respond with the information it's given from RAG. But overall, it does have the right answer, and it's talking about robotic pets, which obviously it is only going to get that if it's using RAG on the meeting notes document that I have uploaded through my Google Drive. So this is working absolutely beautifully. Now, I would probably want to do a lot more testing with this whole setup, but just to keep things simple right now, I'm going to leave it at this as a simple example. But yeah, I would encourage you to just take this forward, keep working on this agent, and yeah, it's fully local. it is just a beautiful thing. So I hope that this whole local AI setup is just as cool for you as it is for me, because I have been having a blast with this and I will continue to as I keep expanding on it. So just as I promised in the start of the video, I want to talk a little bit about how I'm planning on expanding this in the future to make it even better. Because here's the thing, this whole stack that I showed here is a really good starting point, but there's some things I want to add on to it as well to make it even more robust. Things like Redis for caching or a self-hosted Supabase instead of the vanilla Postgres, because then I can handle things like authentication as well. Maybe even turning this into a whole local AI tech stack that would even include things like the front end as well, or maybe baking in best practices for RAGs and LLMs or end-to-end workflows for that to make this more of like a template as well to actually make it really, really easy to get started with local AI. So I hope that you're excited about that. If you are, or if you found this video just helpful in general, getting you set up with your local AI tech stack, I would really appreciate a like and a subscribe. And with that, I will see you in the next video.